So what they did is they finally came up with a way to fix that. They controlled it by linking a computer to an ADC. We all know what an ADC is, right? Air-to-air computer. And that controlled the wing sweep, so it was optimized where the wing would sweep to the exact angle that it needed to be at for the airspeed that the aircraft was currently at. This is the wing box on an F-14. This is where the actual wing sweep happens. It's fixed here, and a jack screw is on the one side of the fuselage, and it'd be the same on the other side, and they unscrew or screw in to change the sweep so it remains constant on both sides. So what happens when we change the wing sweep? Well, a couple things we already talked about, right? That center of pressure changes. Some other things happen too, which can be beneficial, but sometimes are not. Wing thickness actually does change because we're sending some of that wing back towards the fuselage. The thickness actually will decrease. Wingspan decreases. Most swing wing aircraft today, the wingspan's cut in half by 50%. So we're losing a lot of lift with that. But when we lose lift, what else do we lose? Right? So induced drag goes down, which helps us when we want to go faster. So getting into some aircraft that actually use this design. First one, F-111. We already talked about it. It was introduced in 1967, and the Su-17 was introduced just a little bit after that. So here it is flying. Next aircraft, MiG-23. This was basically the Russians' answer to the F-111 and future swing wing aircraft. This was from a ground-up design. They didn't cut anything off a different airplane to make this one. This was, hey, we start out, we need this, this, and this. We're going to build that. Next aircraft, the Panavia Tornado. This is used by the RAF and the Luftwaffe today, and it is a swing wing aircraft. Kind of cool thing with this, you see the wing pylons out there. What happens is when you swing the wing, obviously the pylons, if they would just swing with the wing, they would create so much drag, you wouldn't be able to fly the aircraft anymore. So they have a wing mechanism in there that as the wing sweeps, the pylons move to stay parallel to the airflow. Of course, if those fail, you're in trouble. Next one, B-1. Really the second biggest swing wing aircraft ever built. Still in operation today. Out of all of these, it is actually one of two that are still left. And of course that was talked about the last time. It did have some problems as well that needed to be fixed. Tu-160. This is the biggest swing wing aircraft ever built. Hint, hint, wink, wink, nudge, nudge, look at your quiz. And obviously by the Russians. So it is a little bit bigger than the B-1. And of course the last aircraft we're going to deal with here, the F-14. So, a couple other ones that we talk about, concept designs. These actually never went into full production. The Switchblade here, once this came out, they actually had solved the problem and they didn't need sweep wings anymore. They just designed the wings to be fixed to the aircraft, and we were going to go without this. Next, who's seen the movie Stealth? Okay, recognize this airplane? Okay. This was actually a concept airplane. They actually built a mock-up of it. It didn't actually fly, obviously, but this is a sweep wing design. Next, one aircraft that did go into production. They didn't mass produce it. They only built one, but it's the AD-1, and it's what's called an oblique wing, meaning that you have one wing. It's a center pivot wing, and it rotates like this, and surprisingly, it's still optimized for the phases of flight. It looks pretty good. I do have a YouTube clip on this one. And they were actually introducing this for use as a transport category solution to low-speed, high-speed problems. There's not a lot of information about this thing. However, just the fact that they're doing that and not crashing is kind of cool. So, lastly here we'll look at the performance data. I did pull this off of the NATOPS manual, which is the Naval Air Training and standardization manual basically for the F-14, and also got a couple things from an article out of Popular Science. Guy actually went for a flight in F-14. The sweep of the wings vary from 20 to 68 degrees. They sweep about 15 degrees per second, meaning that it takes around 9 seconds to go from fully unswept to fully swept. Sweep rate, and this thing is able to go Mach 2, actually has gone over Mach 2. But this is where the cool part comes in, landing. They unsweep this thing to 20 degrees wing sweep. Then you come in, they have full flaps, full slats, and speed brakes. No reversers, no drag parachute. They come in at 120 knots, which is relatively unremarkable. 12-degree pitch up, which is about what we landed Cessna at. And they were down and stopped at 1,000 feet. This is a twin turbojet aircraft that can go Mach 2, 1,000-foot ground roll. So, which would never be possible without variable sweep wings. And in fact, they can land with the wings fully swept back. Their approach speed then becomes over 200 knots. It's been done. They've actually landed it on the carrier with the wings fully swept back. So F-111, it handled pretty well. They just had those problems with wings not being swept for the right speed. But it was very stable at low altitude when they had that working correctly. The B-1B, like we heard last time, it had some center pressure issues. When you design an aircraft that huge, you're still going to have that problem. So what they ended up doing was transferring fuel to change the CG while you're sweeping wings. So, what should we have learned from all this stuff today? Well, one, major technological advancement. This thing led the way for all aircraft that were coming into play in the Cold War. Even if some of them don't use this, it helped design a wing that doesn't need it. It was a solution to a complex problem. So at the time, this was the best in the business. There are still a couple aircraft in use today that use this, and if they didn't, there's no way they'd be flying. B-1 is one of them. And it just paved the way for that new aircraft design. So, questions? You got anything on the quiz? Questions? Bueller? Cool. Here's my sources. Thanks.